Hello and welcome back to Mech Zone. Today we are going to start with a very important problem statement, that is transportation problem. And in the transportation problem, the main aim is to transport the goods from their sources to their destination. Now, what is important is we have to transport these goods from one place to the another such that the cost of transport is minimized. Okay, so two types of problems will be faced here. And we will generally encounter the balanced problems, that is when the supply is equal to the demand, then the problem is said to be balanced, and when the supply is not equals to the demand, then it is called as an unbalanced problem. Now the main aims are two, that is we have to obtain the initial feasible solution, and the next is optimization. Now in the optimization part, it is actually very lengthy and quite complicated, so optimization is not asked, whereas only feasible solution is asked by most of these examinations. And this question will be given in the form of a matrix in the form of rows and columns. And here we are having three sources, 1, 2 and 3, and these are the destinations A, B and C. The elements which are written inside these cells actually correspond to the transportation cost per item. Okay, and here is given 200, means demand is 200 and supply on this side. So demands are on this side and supply are in this side. Now in order to find out the feasible solution, we will discuss three main important techniques to solve this type of question. The first technique that we are going to use is the northwest corner rule. Now we will be discussing three main techniques, that is the northwest corner rule, the least cost method and the Vogel's approximation method. Now to start with the northwest corner rule, what we will do is we will select the cell or the element or the block which is present on the northwest corner of our diagram. So if we look at this diagram, this is the northwest corner of the diagram. So before we start solving any problem, we first have to check whether the problem is a balanced problem or not. So this is the diagram that has been given to us. First we will check whether the problem is balanced or not. So for the balanced problem, total supply should be equal to total demand. So 250 plus 350, this would become 600. 600 plus 400 would become 1000, and this would become 1200, and for this we have 549 and 3 1200. So supply is equal to demand in this case, so therefore it is type of a balanced problem. Now what we will do is we will look for the northwest cell or the northwest corner of our diagram, and we will start the allocation of our resources from that particular column, or sorry, from that particular cell. Now this is the northwest corner or the northwest cell of our diagram. It is having a demand of 250 and the supply is 300. Now the supply is more and the demand is less. We are always going to fill up the least value out of the demand or the supply. So out of 250 and 300, the least value is 250. So what we have done is we have allocated 250 in this block, and after allocating 250, this would become 0. Now when a particular column or a row becomes 0, we are going to cancel it. Since all the allocation has been done in this box, this entire column becomes 0. Now we will forget about this entire column. So this now becomes our main matrix. And then again we will look for the northwest corner, and the northwest corner corresponds to this cell. Now this cell has a demand of 350 and the supply that is available is only of 50. So out of 50 and 350, the least value is 50. So we have allocated 50 here. Now when this becomes 50, we will deduct 350 में से 50 minus कर देंगे and we will obtain 300. And 50 that was left, it has been allocated, so it becomes 0. Now since this becomes 0, the entire row will be neglected. Entire row will be neglected. Now we will hide this row also. Now 1, 2, 3, 4, 5, 6, this becomes our main matrix. So again this becomes the northwest corner, and the demand is about for 300 and the supply available is 400. So out of 300 and 400, the least value is 300, and hence we are going to allocate the least, that is the 300, to this cell. Now when 300 has been allocated, 300 minus 300 becomes 0, and 400 minus 300 becomes 100. So here, since it becomes 0, so this column gets exhausted out. Now we will hide the exhausted columns. How many columns are left now? 1, 2, 3 and 4. Now again in this diagram, this is the northwest cell. Now for this cell, the demand is of 400 and the supply available is only of 100. क्योंकि 400 को तो 300 इसमें से पहले ही दे देता, therefore 100 is only left. We are going to allocate the least, that is the 100, in this cell. Now when 100 has been allocated, 400 minus 100 will give you 300 and 100 minus 100 will give you 0. Now when this row has been fully satisfied, we are going to cancel this entire row. Now what becomes? We are left with only 2 cells. Now this becomes our northwest cell. The demand is of 300 and the supply is of 500. So the least is 300, therefore we are going to allocate 300 here. And what we will do is, we will subtract 300. So 300 minus 300 becomes 0 and 500 minus 300 becomes 200. So this has also been satisfied. So we are now going to reduce, मतलब अब इसके बाद तो ये column वैसे ही पूरा खत्म हो गया था. Now we will come to the last cell. Supply and demand both are 200. In the Palace problem, we will see that in the last allocation, the supply and the demand will be exactly equal, and hence we have allocated 200 here. Now, I hope the procedure has been very simple and is easily understandable. Now we will find out the total cost of allocation. So how will we find out? We will concentrate our attention only on those boxes where we have done the allocation. That is this box, this, here, here and here. So what we will do is, we will multiply the box number along with the cost which is associated with that element. So 250 multiplied by 3, and we will add these together, plus 50 into 1 plus 300 into 6 plus 100 into 5 plus 300 into 3 plus 200 into 2. So the total cost that would be obtained is 4400 rupees. In the examination, exact method can be asked. For example, you need to solve the particular problem by either Vogel's approximation, by column minima, by row minima, or by the least cost method, or by northwest corner rule. However, there are 2 more methods which I am not concentrating upon, that is the row minima and the column minima differences. Now we have obtained the solution, by feasible solution, by one of the methods. Now we switch over to the second method, that is the solution by the least cost method. Okay, the solution by the least cost method. Here what we are going to see is, we are first going to look at the cell which is having the least cost. So 317426598332. So the least cost is corresponding to this cell. So the cell which is having the least cost will be allocated first. So for this particular cell, the demand was 350, but the supply was only 300. So we allocated the minimum, that is the 300, to this cell. So this becomes 0, and 350 minus 300 becomes 50. Now when this particular cell has been exhausted, we see that here is 0. So this entire column becomes 0. Okay, this entire column becomes 0. Now we look for the second minimum cost. Okay, the second minimum cost here is 2, but we can see 2 at 2 places, here also and here also. So we can start our allocation either from here or from here. The answer will not be affected. So what I have done is, I have started my allocation from here. So the demand is 250 and the supply is 400. So the minimum of these two values is 250. So I have allocated 250 at this place, such that 250 minus 250 becomes 0 and 400 minus 250 becomes 150. Now this has also been done, so this completely becomes exhausted. This was also exhausted, this was also exhausted. Now next least cost was 2, so we will allocate here. Demand is 200 and the supply is 500, so we will allocate 200 here. So 500 minus 200 becomes 300. Okay, now this has also been allocated. Okay, now what is left? The left was next least cost is 3. So 3 is here also, 3 is here also. You can allocate any of these first. So what I have done is I have done here first. So demand is of 50, supply is of 300. So what we will do is we will allocate only 50 here, and 50 minus 50 becomes 0 and 300 minus 50 becomes 250. So this entire has been allocated now. Okay, the next least cost after 3 becomes this 3. So the demand is 150. Sorry, the demand is 400 and the supply is 250. So the least is 250. So we have filled 250 here, and we will subtract 400 में से 250 becomes 150. So this becomes 0. Therefore, this entire row has been exhausted. Now the only cell which is left is corresponding to 5, and the cell which is corresponding to 5, it has a demand of 150 and the supply is also of 150. So this becomes 0. Now again we will apply the same procedure. Box digit multiplied by the cost, that is 300 into 1 plus 250 into 2, 150 into 5 plus 50 into 3 plus 250 into 3 plus 200 into 2. And on adding all these digits together, we will obtain that the cost is coming out to be 2850. And when we did it from the northwest corner rule, we saw it was 4400. Now it is 2850, and we see that the cost has reduced by this method. So the next method that we are going to apply for obtaining a feasible solution is Vogel's approximation method. Now this method is quite complicated, but it is the most preferred method. What we are going to do here is we are going to calculate the row difference and the column difference, and corresponding to the largest difference, the one which is having the least cost, we are going to allocate that cost first. So this method is actually involving calculation of row differences and the calculation of column differences. Now, if we look at the diagram, what we will do is we will find out the row difference, and the row difference can be calculated by subtracting the minimum values corresponding to that particular row. Now if we look in the first row, the minimum values are 3 and 1. So we will subtract 3 and 1 and the corresponding difference would be 2. For the second row, it would be 5 minus 2, that is 3. And for this row, it would be 3 minus 2, that is 1. So what we have done here is we have written the row differences here and the column differences here. So the first difference for the first row difference is 2, second row difference is 3, third row difference is 1, first column difference, that is the difference between 3 and 2, is 1, between 1 and 3 is 2, between 5 and 3 is 2, between 2 and 4 is 2. So we would find out the largest difference first. So the largest difference is 3. Now corresponding to this largest difference, which cell is having the minimum cost? So this is the cell which is having the minimum cost. So we will start our allocation from this process, or sorry, from this cell. Now the demand is of 250, the supply is of 400, so we will allocate 250 here. So this 250 gets cancelled out and 400 minus 250 becomes 150. So we have allocated here, so this becomes 0, so the entire column gets exhausted out. Now once the exhausting process is done, we will again find out the row difference and the column difference such that we will neglect this portion. So 1 minus 4, that is 3, 5 minus 6, so 6 minus 5, that is 1. 3 minus 2, that is 1. And for this particular column, the difference is 3 minus 1, that is 2. 5 minus 3, that is 2. 4 minus 2, that is 2. Again, we see that the largest difference is 3, and corresponding to the largest difference, the smallest element cost is 1. So now we will allocate this place. Demand is 350 and the supply is only 300. So we are going to allocate only 300 here. So 300 allocation done here. So 300 minus 300 becomes 0, and 350 minus 300 is 50. So now since this is completely exhausted, we will leave out this. Now our problem is reduced only to 1, 2, 3, 4, 5 and 6 element cells. Again we will find out the row difference and the column difference. Now for this upper row it has been cancelled, so I have written a dash. Now for this row the difference would be 6 minus 5, that is 1, and 3 minus 2, that is 1. Okay. Now for this column, 6 minus 3, that is 3. 5 minus 3, that is 2. 9 minus 2, that is 7. So now the largest difference is 7, and corresponding to 7, this is the least cost, this is the least cost of the element. So now we are going to allocate here. Demand is 200, supply is 500, so we are going to allocate 200 at this place. So 200 and minus 200 becomes 0, and 500 minus 200 becomes 300. So this entire goes off. Now again we will find out the row difference and the column difference. It is here we will still get dash, here it is 1, actually 0 is wrong, we should write dash. For this particular column it becomes 6 minus 3, that is 3, 5 minus 3, that is 2, and since this column is exhausted, so the difference will be dash. Now the largest difference is 3, and corresponding to 3 the least value is 3. So we will allocate next here. Now availability is only 50, that is demand is only 50 and available is 300. So we will allocate 50, and 300 minus 50 would be 250. So this entire goes off. Next is this one. Now we will not calculate the row and the column difference because now only 2 elements have been left. So since it is having the least cost, we will fill it first and then 5 will be filled. So here only 150 is the, 200 and for this particular cell, 250 is the supply and 400 is the demand. So we will allocate only 250 here, and the left is 150, and here it becomes 0. Now for this particular cell we see 150 is the demand and 150 is the supply. So we will allocate 150 here. Now we will apply the same procedure, that is 300 into 1 plus 250 into 2 plus 150 into 5 plus 50 into 3 plus 250 into 3 plus 200 into 2. So that would give us the total cost, and the total cost is coming out to be the same as that we have obtained in the previous method, that is 2,850 rupees. But we see that the Vogel's approximation is the generally most preferred one. However, in the examinations, if the method is not given by which method you have to solve, you can apply any method. Now please note, in the objective type questions, first try to solve it by northwest or either by Vogel's approximation. But if it is a 2 marks question which is an integer type, so you can solve it by any method if it is not specified, and if it is still specified then we have to follow that method. So with this we come to the end of this lecture. We hope you are enjoying our lectures. Please give us your valuable feedbacks on our channel. You can also rate our Facebook page, where our Facebook page description is also given in the description section of this video. You can download the study material absolutely for free, and you can also suggest our lecture to your friends so that they may also be benefited. So with this we come to the end of this portion. We hope that you are enjoying our lectures. Stay tuned to our channel for more videos on mechanical engineering subjects, and thank you for today.